The first question is about addition of two 6-digit numbers, and what we are given in the problem um, is a representation of the numbers by alphabets, and there are 3 rows. The first 2 rows are the two numbers, and the third row is the sum of the numbers. And we have been told that each of the numbers 0 to 9 is represented by one of the alphabets A to K, and each of the letters represent one of the numbers. So this is what we are told. Now before we start, we need to understand one very simple concept. So let's say we have a number 999, 9 being the highest one-digit number, single-digit number, and we are trying to add these two numbers. Now notice that 9 plus 9 is 18, and the carryover is 1. Again, 9 plus 9, 18 plus 1, 19. We get a 9 here, and the carriover is 1. And then 1 plus 9 plus 9 becomes 19, which means 9 comes here, 1 is carried over, and 1 comes down. So you see that the maximum carryover can only be 1. The only carryover in any addition of two numbers can only be 1. There cannot be any other carryover. This is the concept that we will need to solve this problem. So now let's look at the problem itself. So you see that in the last column we have 3 F's, which means there is a number such that that number F plus F gives you F or 10F. Why 10F? Because if we have 10F, then F will come here and 1 will get carried over. So let's see what numbers are possible here. So 0 plus 0 is equal to 0. This is the only possibility where we have a summation of two same numbers giving the same number. There is no other way that this can happen. 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, and so on. 9 plus 9 is equal to 18. So there is no other way that you can get the same number when you are adding two same numbers. So therefore F becomes equal to 0. Now we see F in two more places in the addition, and we equate them to 0. Now let's look at the number A. Now as I told that the maximum carryover is equal to 1. Okay, so as we saw here, so whatever number is coming here, there is a number being carried over here, which is 1, which is being written as A. So A is equal to 1. So this is 1, 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 and this is 1. So we got the value of A and F now. Now let's see what we are left with. So we are left with B. Now we can see that in this column, second column, we see B plus 1 is giving 11. So 1 is coming here and 1 is getting carried over. So therefore B is equal to 10, but B cannot be equal to 10. So which means that there is something which has been carried over, which is 1. The only possibility is 1. So 1 would have been carried over here, and then 1 plus b plus 1 is equal to 11, which means b is equal to 11 minus 2, or b is equal to 9. So the value of b comes out to be 9. Now we don't have b anywhere else. Now you see that we have a 1 carryover here and a 0 here, which means h plus h is equal to 10. So h plus h is equal to 10, or h is equal to 5. Now notice that there cannot be any carryover here, because if the carryover is 1, then we cannot have two numbers h and h which gives 10, because in that case 2h will be equal to 9, which will not yield any value for h. So therefore there is no carryover here, so h becomes 5, and therefore we get the value of h equal to 5. Now let us look at this column where we have a plus f is equal to a plus f is equal to c. Now notice that the value of a is 1, so 1 plus 0 is equal to c, and in that case c is equal to 1, but we already have the value of a equal to 1, and therefore c cannot be 1. C cannot be 1 because it is told that each of the letters represent a distinct digit. So since a is already 1, c cannot be 1. So therefore there has to be a carryover in this column, which makes c equal to 2, because 1 plus a plus f is 0 is equal to c. So a is 1, so c is equal to 2. So we got the values of c, f, a, h and b, and we are left with j, g and k. So just let me clear up the board a little bit. So we are left with the values of j, g and k, and notice that we already have the value of a equal to 1, b equal to 9, then we have h equal to 5, f equal to 0 and c equal to 2. So 0 is gone, 1 is gone, 2 is gone, 5 is gone, and 9 is gone. So what we are left with are 3, 4, 6, 7 and 8. So the values of j, g and k can only take values of 3, 4, 6, 7 and 8. Now we notice that in this column there is a carryover of 1 from this column. So the value of a is 1 here. So therefore g plus k is equal to 11, because here we had a 0, there was no carryover here. 0 plus 0 is 0. There is no carryover from here. So therefore carryover is 0 here. So g plus k is 11 is one relationship we get. And then here we have c equal to 2. So no carryover. So we have A plus J equal to G, or 1 plus J is equal to G, which means J is equal to G minus 1. So these are the two relations we have, but we cannot uniquely find out the value of J, G and K because we have two equations and three unknowns. So now let's see the possibilities. So suppose we take the value of J as 3. So J as 3 means G is equal to 3 plus 1. So G would be 4. And if G is 4, then K becomes 7. So this is 7. So this is one possibility. Next, let's assume J to be 4. If J is 4, then G becomes 4 plus 1 equal to 5, and K becomes 6. But 5 is already taken up by age, so this cannot happen. This is not possible. So next we take the value of J to be 6. So if J is 6, then G is J plus 1. G becomes 7 and K becomes 4. So 6, 7 and 4 is possible. Now next we assume the value of J to be 7. So if J is 7, then G is 7 plus 1, 8, and K is 11 minus 8, which is 3. So this is another possibility. And let's try the last value of J to be 8. If J is 8, then G becomes J plus 1, which is 9, and K becomes 11 minus 9, which is 2, but this is not possible because 9 is already taken up by B. So this set is not possible. So there are only three set of values of J, G and K which are possible, which is 3, 4 and 7, 6, 7 and 4, and 7, 8 and 3. So this is the solution of this problem, and we cannot uniquely solve for the values of J, G and K because we don't have the third equation. We only have two equations. So now let's go to the questions. So the first question is, what digit does the letter A represent? We already found that out. A is equal to 1. So this would be 1. The next question is, which digit does the letter B represent? We found out B to be 9. So this is 9. The third one says, which among the digits 3, 4, 6 and 7 cannot be represented by the letter D? Now notice that we did not have D in the picture at all. So how do we ascertain D? So we note that we already have J, G and K values, rather the set of values for J, G and K that are possible, and from that we note that the number 7 is appearing in all three cases. So the number 7 can only be assigned to either K or G or J. So number 7 cannot go to any other alphabet. So apart from J, G and K, number 7 is not possible to be taken up by any other alphabet. So D cannot have the value of 7. So it can have the value of 3, 4 and 6, because let's look at the first set. So 3, 4 are there, 6 is not there. So 6 can be taken up by D. But 7 is not possible, because 7 is going to be needed in all the 3 cases. So therefore 7 cannot be taken up by the letter D. Now let's go to the last question. Which among the digits 4, 6, 7 and 8 cannot be represented by the letter G? Now we see the value of G that has come out. So 4, 7 and 8 are clearly 3 values of G which are possible. So 4, 7 and 8 are possible values of G. 6 cannot be a possible value of G from the set of solutions that we have derived. So 6 is the correct answer.